Assalamualaikum class. Hope you all are fine. Alhamdulillah, I'm also fine. Here is Miss Rouge, and as you all know that today we are studying about the mathematics. So class, first of all, in the last lecture I gave you an introduction about the syllabus, the topics, a revision, a recap, a reinforcement of the things. So in this lecture we are going to start our syllabus, our learning process. The book which we followed is Oxford New Syllabus Mathematics 7th edition, book 1. In our class we have to take the reference from book 1 and book 2 also. Few chapters from book 1 and few chapters from book 2. So class 7th, the chapter which I am starting to explain is chapter number 4, Basic Algebra and Manipulation. Today I am giving you a brief description about the topic. Also I attach few links and videos in it which help you to clarify your concept about the algebraic expressions and algebraic equation, and how we solve the algebraic equation and expression, that is linear equation or linear expression. So class, in this lecture, the introduction lecture of chapter number 4, the first lecture you can say, the things which we are considered is like algebraic expression. What is algebraic expression? We are giving a basic example, basic definition of it. Then we are classifying that, simplifying and evaluating algebraic expression and its equation, evaluation of algebraic expression. Then we are finding out the linear expressions. In linear expressions, we are solving the problems with the help of related video, that how can we solve the linear expression, how can we do the addition and subtraction in the linear expression. Some related videos are there and some links are there. You have to go with them and you can solve your queries and problems. As well as I am also here whenever you want to contact me and whenever you want my guidance, I am here. So don't you worry. So now the thing is that, what is algebraic expression? Why we are saying it expression? First of all, we need to know what is algebra. In our introductory lecture, I am giving you an example that what is the algebra, why we learn the algebra. Basically, there are three types of mathematics mainly. There is arithmetic, algebra and geometry. Arithmetic is the basic concept which we are using in our daily lives. Geometry is related to the shapes, spheres, triangles, rectangles and whatever all. And algebra, why we are using algebra? Because sometimes in some situation we don't know the actual situation. We have to assume the things, and to assume the things we denote these things with the expressions, with the variables, and all it's come under the umbrella of algebra, where we assume things and then solve it. It is a phenomena of nature that nothing can be stopped. We have to keep going. Same as that, to solve any problem, we can't say I can't do this. We have to do this and we have to do the effort for it. So if we don't know anything, we just have to assume it, and in the last we automatically get the answer of it. It's a simple explanation of algebra. Now coming towards algebraic expressions. An expression that consists of algebraic expression and algebraic term, operations, symbols, plus, minus, multiplication, division or bracket is known as algebraic expression. In a basic term, I can say that there are two or more words or symbol are there, and in between there is any four operation is present: plus, minus, addition, subtraction, means, and multiplication and division, and we have to solve it. That is called algebraic expression. There is a picture in which I describe that 5x minus 3, it all the algebraic expression. Here 3 is constant, x is variable, means unknown, and 5 is the coefficient, means 5 times of x minus 3. It is expression. Hope you understand it. Now considering the first topic, that is simplifying and evaluating algebraic expression. First of all, we have to know that what is algebra. There are three parts of the mathematics. First one is arithmetic, second one is geometry, and the third one is algebra. Basically, in algebra, there are some unknown values which we have to find out the answer of it. So, in the first column, we are seeing that there is an expression that is called algebraic expression. So what is the difference between the algebraic expression and the algebraic equation? In the algebraic expression, we have a number with a variable and a constant. We have a coefficient, we have a variable, that is any alphabet which is unknown, and the constant. And in the equation, we have these algebraic expression with the sign of is equals to, like x square plus 6x plus 9 is equals to 0. The thing which is differ between the algebraic expression and algebraic equation is the sign of equals to. When we are balancing the two things, it is called the equation. And when we are just writing something in the algebraic form, it is called algebraic expressions. Hope you understand it.
In this video, we're going to focus on evaluating expressions with variables, fractions, and exponents. But let's start with the basics first. What is 7 plus 4 times 3? Go ahead and evaluate that expression. Now, there's two ways that you might be thinking of doing this. Should we add before we multiply, or should we multiply before we add? If we add first, 7 plus 4 is 11, and 11 times 3 is 33. But if we multiply first, 4 times 3 is 12, 7 plus 12 is 19. If you type this exact expression in a scientific calculator, it is going to give you this answer, 19, and not 33. And the reason for that is something called order of operations. There's a certain way in which you need to perform mathematical operations. Perhaps you heard of the term PEMDAS, which is very helpful to know the order of operations. Basically, P stands for parentheses, E is for exponents, M is for multiplication, D is for division, A is for addition, S is for subtraction. So parentheses has the highest order. Then come exponents. Multiplication and division are equal, and for addition and subtraction they're the same. So towards the left, those operations have more priority. So comparing addition versus multiplication, multiplication's on the left side, so we need to multiply first before we add, and that's why the answer is 19. Here's another example. 36 minus 12 divided by 3. So go ahead and take a minute and try this example. Should we subtract before we divide, or should we divide first and then subtract? Well, let's consider the expression PEMDAS. Notice that division has more priority than subtraction since it's on the left side. So we need to divide first. 12 divided by 3 is 4, and 36 minus 4 is 32. So that's the answer. Now let's move on to our next example. What is 24 divided by 6 multiplied by 2? Should we divide before we multiply, or should we multiply first and then divide? Well, let's do it both ways. Let's divide first. 24 divided by 6 is 4, and 4 times 2 is 8. Now let's do it the other way. Let's multiply 6 by 2. That's going to be 12, and 24 divided by 12 is 2. So here we can see that we get different answers, so the order matters. If you type this expression in exactly the way you see it in your calculator, it will give you 8 as the answer. Multiplication and division, they have the same priority. So if you have a situation like this, the best thing to do is simply perform the operation from left to right, and it will give you the right answer. Another way you could see this expression is 24 divided by 6 is a fraction, and then you're going to multiply by 2, which is the same as 2 over 1. So if you divide 24 by 6, you're going to get 4, and 4 times 2 is 8. The other way to do this is to multiply 24 by 2, which is 48, and then divide it by 6. That will also give you 8. Here's another one. 8 times 5 divided by 4. So go ahead and try that. For this example, the best thing to do is simply to multiply from left to right. 8 times 5 is 40, and 40 divided by 4 is 10. And so that's going to be the answer. By the way, in this particular example, if you divide first, you're going to get the same answer. 5 divided by 4 is 1.25 as a decimal. And if you multiply that by 8, this will also give you 10. Try this example. What's 24 plus 12 divided by 10 minus 4? Go ahead and simplify that expression. 24 plus 12 is 36. 10 minus 4 is 6. 36 divided by 6 is 6. And that's all you got to do for that one. What is 4 multiplied by the sum of 3 plus 5 minus the product of 7 and 2? Now going back to the PEMDAS expression, parentheses has the highest priority compared to multiplication and addition and subtraction. So we got to work the operation that's inside the parentheses first. 3 plus 5 is 8. And now we need to multiply. 4 times 8 is 32, and 7 times 2 is 14. And now we can subtract. 32 minus 14, that's going to be equal to 18. And so that's the answer for this example. Here's a harder example that you could try. What is 3 multiplied by 4 minus 2 times 3 to the third power minus 2 to the fourth power plus 8 times 2? So the first thing we need to do is work on the inside of the parentheses. So we got to start deep within the brackets. Now we have some exponents. So what is 3 to the third power? When you're dealing with exponents, you need to think of it as repeated multiplication. Basically, this means that we're multiplying 3 3's together. 3 times 3 is 9, and 9 times 3 is 27. So 3 to the third is 27. Now what about 2 to the fourth? So this expression means that we're multiplying 4 2's together. 2 times 2 is 4, and 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th is simply 16. So right now, this is the expression that we currently have. So we have 27 minus 16 on the inside. And 8 times 2, we could just go ahead and make that 16. Now, what is 27 minus 16? 27 minus 16 is 11. Next, we have 11 times 2, which is 22. And then we have 4 minus 22, which is negative 18. And 3 times negative 18, that's negative 54. Another way in which you could do that is think of 18 as being 10 plus 8. 3 times 10 is 30, and 3 times 8 is 24. 30 plus 24 is 54. Now, you can also do it this way. 8 times 3 is 24. Carry over the 2. 3 times 1 is 3, plus 2, that's 5. That works as well. So now we have negative 54 plus 16. And if we use the calculator for that, this should give you negative 38. So that's the answer for this expression. Now let's say if we have an expression that contains variables. 4x plus 2y minus 3z. And let's say that x is equal to 2, y is equal to 3, and z is equal to negative 4. Go ahead and evaluate this expression. So what we need to do is substitute. We need to replace x with its value. X is equal to 2. So let's replace it with 2. And then let's replace y with 3. And then we're going to substitute z with negative 4. 4 times 2 is 8. 2 times 3 is 6. Negative 3 times negative 4 is positive 12. 8 plus 6 is 14. 14 plus 12 is 26. And that's how you can evaluate an algebraic expression. Here's another example. X squared plus 3y cubed divided by 2z plus 1. Now let's say that x is equal to 4 and y is equal to 2. And let's say z is 4.5. Go ahead and evaluate the expression. So we're going to have 4 squared plus 3 times 2 to the third divided by 2 times 4.5 plus 1. 4 squared, that's 4 times 4, that's 16. 2 to the third, that's 2 times 2 times 2, which is 8. And 2 times 4.5. 2 times 4 is 8. 2 times a half is 1. 8 plus 1 is 9. So 2 times 4.5 is 9. Now, 3 times 8 is 24, and 9 plus 1 is 10. 16 plus 24 is 40. 40 divided by 10 is 4. So that's the answer for this example. Now, this is going to be the last example. So the expression is 4 times x plus y minus z divided by 3. And let's say x is 3, y is 4, and z is 12. Go ahead and evaluate the expression. So once again, all we need to do is replace x and y with 3 and 4, and then substitute z with 12. 3 plus 4 is 7, and 12 divided by 3 is 4. 4 times 7 is 28. 28 minus 4 is 24. And so that's the answer for this example. So as you can see, you just got to perform the operations when evaluating expressions.
So class, after explaining the definition and proper form of algebraic expression and equation, difference between the expression and equation, now we are moving towards Evaluation of algebraic expression. What is expression? What is algebraic expression? And how we evaluate it. Evaluating an algebraic expression means finding out the value of expression when the variable take on certain values. For example, if we have an example like 4x minus 3, 4 is the coefficient, x is the variable, minus is the mathematical operation, and 3 is the constant. We don't know the value of x, it is a variable. To evaluate the algebraic expression, if we assume that the value of x is 4 or 5 or 6, we have to put it and take the proper answer. It is called the evaluation of algebraic expression. I also add a video related to this which help you further to solve this concept, inshallah.
Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to talk about adding and subtracting linear expressions. Let's get started. All right, before we get to the definition of what a linear expression is, here is a table showing examples of 3 linear expressions, and here are 3 non-linear expressions. And I want to see if you're able to see the difference and see if you can figure out what makes a linear expression. So I'll give you a second and wait. Okay, did you figure it out? Well, hopefully you noticed that all of the x's, all the variables in the linear expressions are to the first power. There's no x squares, there's no x cubes or any of that. But in the nonlinear expressions, yeah, we've got an x squared, we've got an x cubed. This is just an x, right? Same as up here, but we also have an x cubed in the expression. And here we've got an x to the 5th. It doesn't matter anything about the constants. Those don't make a difference. It's all about the variables. So, the definition for a linear expression is an algebraic expression in which the exponent of the variable is 1. All right, let's break that down a little bit. Algebraic expression, algebraic, that just means it has variables, right? Expression, there's no equal sign, right? Just like these. These are all expressions. There's no equal sign. It's not an equation. In which the exponent, here, up here, you can't see it, but there would be 1 there. The variable is 1. So that's just like we said. That exponent is 2. That exponent is 3. That one's 5. Those are nonlinear. For it to be linear, the exponent on the variable has to be 1. And the reason for that is if you look at the word linear, you should notice something in there. Hopefully you notice the word line. They're called linear expressions because if you graph them, you're going to get a straight line. No matter which one of these you graph, it's always going to be a straight line. However, nonlinear expressions, like an x squared, is going to look something like this. Like that. And then cubed, those look something like this. It's not perfect, but those are not straight lines, and that's why they're called nonlinear expressions. All right, let's get to our first example. Okay, example 1, we are finding the sum. We're adding linear expressions. So here's a linear expression plus another linear expression. And all we're doing is adding them together. We're simplifying this big, long expression. For this one's fairly simple. There's nothing to distribute. I don't have to use the distributive property. And it's addition, so I can use a method where we just line them up vertically. So I could say x minus 2 plus 3x plus 8. So I can think of this minus 2 as a negative 2 because x minus 2 is the same as x plus a negative 2. And then that's a positive 8. So if I add them together, negative 2 plus 8 would be 6, positive 6. And 3x plus x is 4x. And again, this was positive, so that's going to be plus 6. So that's the vertical method of adding linear expressions, 4x plus 6. Let's look at part B. I'm going to do this a little bit differently. I'm not going to do it vertically like this. I'm just going to add it horizontally. There is nothing to do inside the parentheses. I can't simplify these linear expressions any more than they already are. There's also nothing to distribute, so I can drop the parentheses. So I'm going to rewrite it as just negative 4y plus 3 plus 11y. And this minus 5, I'm going to make it into plus negative 5. And that just allows me to move things around, right? And I can combine my like terms now. So negative 4y plus 11y is the other like term, so I'll write that there. Plus 3 and then plus negative 5. Here are like terms. And here are like terms. These are the constants. When you get really comfortable with it, you're going to be able to do this in your head without rearranging. But once you get comfortable, you'll probably skip this step. Negative 4y plus 11y would give me 7y. Positive 3 plus a negative 5 would give me plus negative 2. But we know an expression is not simplified all the way until there's no parentheses. So this plus negative 2 is going to become 7y minus 2. No more parentheses and no like terms. Let's try another example. Okay, example 2. Simplify. Again, first thing I'm always going to look for is inside the parentheses, is there anything to simplify first? There's no like terms here. There's no like terms here, so I can't do that. So now I'm looking and I see I need to distribute this 2. So that's going to be my first step. The 2 is going to be multiplied by all the terms inside the parentheses. So 2 times negative 7.5x would be negative 15x plus 2 times 3 is 6. And then I have plus, since there's nothing to do in here, I can get rid of those parentheses, plus 5x minus 2. Here are all my terms. I'm going to do something a little bit different. I'm not going to rewrite it as an addition expression. I'm going to use a different method to identify my like terms. I'm going to circle my like terms. So this negative 15x, we'll go blue circle, and this 5x right there, that positive 5x, those are like terms. I have a positive 6 and a negative 2. It's minus 2, but we know we can rewrite that as plus a negative 2. When you do this method, by circling like terms like this, whenever you have a subtraction, you include that with the next term. So it becomes a negative whatever. And then all you're doing in between, the operations in between will always be addition. So negative 15x plus a negative 5x would give me negative 10x. And then my red, these are also like terms, the constants, positive 6 plus a negative 2 would give me positive 4. So plus 4. There are no parentheses and there's no like terms, so that is simplified as far as it can go. Here's some to try on your own. Okay, here's our last example. We've already added linear expressions. Now we're going to subtract. We're going to find the difference of linear expressions. So part A, 5x plus 6, that linear expression minus negative x plus 6. For subtraction, the way you're going to think about it is this subtraction, we are going to distribute it to all the terms inside, which means it's just going to turn everything to the opposite. If you times everything in here by negative 1, it's essentially making them all the opposite, all the terms. So this is still 5x plus 6. There's nothing to simplify in there, so I can get rid of the parentheses. And then minus a negative x, that turns this into plus x. And then this minus a plus 6 becomes minus 6. Distribute that to all the terms in here. So it changes that negative x to positive x, and this plus 6 to minus 6. Now I can just combine my like terms. 5x plus x would give me 6x, and plus 6 and a minus 6 is going to be 0. So that is just going to be 6x. For part B, same thing. I'm going to need to distribute not only this negative or this minus, but also the 2. Starting here, there's nothing to do in the parentheses. So again, that just is 7y plus 5. But then I'm going to distribute a negative 2. That's really, really important. When you have this minus and then a number in front of the parentheses, distribute the negative number to the 4y and to the minus 3, or the negative 3. Negative 2 times 4y is going to be negative 8y. Negative 2 times negative 3, I'm thinking it as a negative 3 because it's minus 3, is going to be plus 6, positive 6. Now, again, just combine your like terms. I have a 7y and a negative 8y. And then I also have a 5, I'll use a red square, and a 6, both positives. So if I combine those like terms, 7y plus a negative 8y is going to be negative 1y, which I'll just write as negative y, plus 5 plus 6 is 11, plus 11. No parentheses, no like terms, so that is simplified as far as it'll go. Here's some more to try on your own. As always, thank you so much for watching, and if you like this video, please subscribe.
Okay class, after the concept of algebra, algebraic expression, algebraic equation, difference between algebraic expression and equation, evaluation of algebraic expression, the next thing which pipelined is linear expression. Here is also linear equation also present. The difference is simply expression haven't any sign of is equals to or balance, and equation have a sign of is equals to. Okay, now moving towards the concept of linear expression. Linear expression is an algebraic expression in which the variable is raised to the first power and not multiplied to another variable or divided. Basically, we can say in the linear expression we are going towards the addition and subtraction, not towards the multiplication and division. But yes, in a case of linear equation, we are going by all the 4 mathematics operation, that is plus, minus, addition, addition, subtraction, division and multiplication. But in a case of linear expression, we only consider the addition or the subtraction, because we haven't the sign of equals to here. Here is a video also attached with this slide, in which I try to explain the addition and the subtraction in linear expression and how can we solve it. Hope you enjoy that video, you understand that video, and surely your concept will be okay, will be fine. And if any confusion, I am here in the next lectures. I am giving you the questions like we are doing in our regular classes. So don't you worry. You just have to focus on your education, on your syllabus. You give your effort and we will put our effort. And combination of all that, we can find out the solution of anything. Hopefully, inshallah. In this last slide, I am giving you some links about the topics. And I highly recommended you to go to these videos of YouTube and watch the concept, because it's a way to online teaching, or you can understand anything by online. So you have to go this because it's really help you. And inshallah, in our next lecture we are going to solve the question like we are doing as in our classes. Yes, there is little bit difference, but hopefully we can achieve the target. So should maintain your morale and have a high courage, because the courage and the efforts is the key of any success. So class, thank you so much. Hope you like the effort, hope you understand the concept, hope you will follow my instruction and my recommendation, and you have to watch all these videos. Thank you so much. I will be coming soon with the next video, with the next lecture, with the next slides, hopefully. Take care of yourself. Thank you.